still writing manual JSON schemas and calling json.loads, stop. You are writing fragile code guaranteed to crash in production. In this video, we switch to modern, crash-free structured outputs using Pydantic BaseModel. Let's build it. Here is the crash point in almost every function calling tutorial out there. They show you how to pass raw arguments with json.loads. But LLMs can easily hallucinate malformed brackets, trailing commas, or miss required fields entirely. When that happens, your application crashes immediately with a JSONDecodeError. It is a fragile mess, and it does not offer autocomplete in your editor. To fix this, we start by defining our tools as Pydantic models. Pydantic lets us declare exact types and field descriptions in clean Python classes. Behind the scenes, the OpenAI SDK compiles this into a strict JSON schema for us. No more hand-rolling hundreds of lines of error-prone dictionary definitions. Let the SDK do the heavy lifting. Instead of the generic completions call, we use client.beta.chat.completions.parse. And we register our tools using OpenAI.Pydantic function tool. This helper automatically configures strict mode. That means OpenAI is guaranteed to respond with a JSON payload matching our Pydantic schema exactly. The SDK intercepts the response, validates it, and mounts the fully parsed object directly onto toolcall.function.parsed arguments. Autocomplete works immediately, and it is 100% crash-free. In a real application, you need to execute these tools in a loop. When the LLM decides to trigger a tool, we retrieve the parsed Pydantic object. We map the function name to our local Python code, execute it using model dump, and append the result back to our conversation memory. It is clean, structured, and easy to maintain. And because we are using modern models, they can invoke multiple tools in parallel. The SDK handles this by providing a list of tool calls in the response. Our loop processes each call concurrently, matching IDs and sending results back to the LLM in one unified history. No duplicate requests, no data loss, just clean orchestration. To recap, always use Pydantic models for strict type validation on function calls. Keep your execution loop stateful and leverage parallel tool dispatch to minimize latency. You now have everything you need to build reliable, type-safe AI agents. Clone the repository below, subscribe for part 2 on multi-agent orchestration, and happy coding.